I'm Francisco Gontad. I'm from AIMEN Technological Center, and I am the project coordinator of Fabulous. Our research is focused on the use of beam splitting, beam shaping techniques for the use of to photopolymerization. So our main goal is to increase the throughput of this technique to be able to fabricate metal surfaces and 3D microstructures on top of different substrates, flat or curved, but with a higher throughput and a very extremely high resolution. The main novelty of AIMEN's research lies on the use of these novel beam splitting techniques, beam management techniques, based on diffractive optical elements and also on special light modulators. We are pushing the limits of the number of beams that can be used for the fabrication of 3D structures with this technique. Probably this is the one technique that allows us to fabricate full 3D shapes on top of different surfaces, which can be of using for the fabrication of different applications like optical waveguides, light pipes, light extraction, light management, and also for the increase of the throughput or the productivity of solar concentrators, solar panels. I think that the main impact of Fabulous lies on the fact that if the technology is successful, and we think that the technology is going to be successful, we will develop a platform for really being able to fabricate things which has not been possible yet in curved surfaces. So for really straightforward applications in the case of filters, optical filters for lenses, spectral bandwidth, full spectral bandwidth lenses or meta lenses will be able to be produced and used commercially for different applications. And that's something that it's not ready yet, but it's something that Fabulous will bring to the market. The possibility to fabricate these tailored optics on top of different optics, providing new functions with broader functionalities and more efficient ways of fabrication. One of the things that I like the most about this project is the fact that even if it's a very nice research project, it's also bringing a technique and products closer to the market. I mean, we are tackling, let's say, a goal which is already challenging from a very research-like project, but without avoiding the final look. I mean, the final goal. We are always looking at the final goal, which is bringing products closer to the market for the European industry, photonics industry. So I think combining both a research-like project with a market, with a final market goal, it's something that it's really challenging, but it's something that it's really good for this project. Yes, of course, using new advanced techniques for optical beam shaping, for laser beam shaping, it's quite challenging, and it helps you deal with all the problems that arise for the use of these techniques and how they can impact the final product. In the past, we have learned that from some failures we might learn and transfer it into new advantages. So the huge challenges that comes out of the project might be the new the learning curve for the future. We can make let's say a positive thing out of a thing that is a real challenge in the present. I mean, there are two main things that we might need to do in order to reach this goal, and one of these is, of course, reach the goals of the project. from a technical point of view. The other way is to being able to communicate to not only the scientific community or the market, but also the final users of the technology, that the way that we can impact their products, or the way that these products can impact their daily life in some aspects, like, for example, the reduction of the consumption of energy, the use of more useful, or let's say more suitable lenses for some applications, with the reduction of the weight of the lenses of these lenses, or an improvement on how we use light, for example, in cars, to avoid some undesired use of stream lighting in other drivers or in the pedestrians. And of course, another thing is the reduction of the amount of materials that we need for the fabrication of these lenses. This is something that will impact the future of a lot of people, because right now the use of natural resources is becoming a huge problem for all the people. So using less material to fabricate more efficient optics, more efficient lights, is going to be something that will help the future, the people in the future.